Okay, here we go.
Take two. Take two from the 403 to the HA. 403 to the HAZ. Just did this movie. You cut me off at the end, so I'm going to remake it and be really paranoid about checking to make sure we're filming. The door so people don't know I'm crazy. Okay. So we're learning about the equation of a line. And the equation of a line is right there. Okay, this is the equation of a line where y and x are variables. X is my input. M and B are known. M is my slope. It's the steepness of my line. B is where my line crosses the y-intercept. Sorry, the y-axis. B always occurs when x is 0 because the y-axis is at x is equal to 0. Okay? Now when I'm working with this slope-intercept form, this is called slope-intercept because we have slope and we have an intercept. It's useful for basically, if I have slope and I have the intercept, it can allow me to calculate points on my line by inputting an x, and it will output the corresponding y-coordinate of that x. Kind of useful, but how do we get here? Okay, so what happens if we are given a slope of a line and just one coordinate on that line? How can we calculate the equation of that line? Well, we do that by using our slope point form of this equation. And the slope point form is like this. Y minus a coordinate y is equal to our slope multiplied by x minus the x coordinate of that y coordinate. So x1, y1 is a point on the circle, on the line, and then y and x are my variables. I will know y1, m, and x1. Those will be given to me, and then I can go from there and I can calculate the slope of the line. So how does that work? Well, I'm going to move this equation over right here. I'm going to put it in green, and we're just going to start playing with it. Okay, we're going to do some textbook problems. Because there's one important thing that we need to know. Okay. So let's look. So I'm on page 372, and they say, okay, for each equation, identify the slope of the line it represents and the coordinates of a point on that line. So they're actually going to give us equations in this form, and we have to interpret them. So the first one they give us is here, okay? They say y minus 5 is equal to negative 4x minus 1. So we are in slope point form. We are in this form here, and you can see I have y. I have my y1, which is 5. I have my slope, negative 4. I have my x, and then I have my x coordinate. Now, the fact that it's y minus and x minus means that y1 is not just, it's not going to be, let me explain. If I have y minus 5, then my y1 is 5, because the equation requires that I subtract y1. So there's always going to be subtraction here, and we have to make it work. So y1 is 5, x minus x1 is 1. It's not negative 1, it's 1, because this negative here is built in. So that's my x1, y1. It's 1 and 5, because y1 ignores the negative. It assumes the negative is built in. So if there's a negative here, then it just is a positive 5. This will make sense in as we do a couple more examples. And then my slope is negative 4. So my slope is negative 4, and the point on the line is 1 and 5. Done. We just solved that problem. Let's do another one. Okay. So this was the one we just did. I'm just going to write the coordinates of x1, y1. It was 1, 5 here, okay? That was the coordinate for this guy. Let's do a different one right below it. So if I had, the next one is y plus 7, And right now all we're doing is we're just learning how to interpret it. Now we're going to use this to actually start creating equations of lines right away here. But first I just want to make sure that we understand this little thing, this little trick. Okay, so again, I am in slope point form. And by looking at this, I can see that my slope is quite easy to see. It's 3. It's right there. And now, I have to rewrite this equation so that I have negatives, okay? Because I need to have this built-in negative there. So I'm going to rewrite this equation before we jump in. And I'm going to rewrite it as this. Y minus, so now I have that built-in minus, which if I subtract another negative, that's how I get a positive there. And then 3x minus 8. Minus is fine. So in this case, yes, my slope is 3, but my y1 is negative 7. It's basically the opposite of whatever sign you see there. And x1 is positive 8. So essentially the trick is x1, y1 are going to be basically the opposite sign of however they show up in the equation here. So if it shows up as positive, it's negative. If it shows up as negative, it's a positive x1. So therefore, my coordinate here on this one is negative 7. Nope. It's 8 for x, negative 7 for y1. And my slope is 3. So try a few of those yourself. But in the meantime, let's actually start playing around with this knowledge. And it's pretty straightforward. So let's say, okay, they want us to write the equation of this graph. And they say, okay, you have a line that has a slope of negative 5, and it passes through the point P, which is negative 4, 2. Okay, that's what they've given us. And so we have a slope, and they gave us a point. So we're probably not going to use this. And now I'm looking at this coordinate here, and I can say, okay, x1 is negative 4, and y1 is 2. So I'm going to use this information, and I'm just going to jump straight into here. So I get y minus y1, which is my point, my y coordinate, my point, minus 2, is equal to negative 5, which is my slope, x minus negative 4. Right? It's always going to be minus. And I'm just subtracting my x1, which is negative 4. And now I have to solve for y. I need to get it into this form, because that's the equation of a line. So to do that, I'm going to rewrite this. I can write it x plus 4 now, knowing that it's going to be the opposite sign. And now I'm going to solve for y. So I'm going to add 2 to each side. And I get y is equal to negative 5 times x plus 4 plus 2. Now, if I want to be in this form, I only have one constant. So I have to expand this multiplication and then simplify it so I can add the 2. So I do that. And I get negative 5x minus 5 times 4 is minus 20 plus 2. So now I can do that, and I get y is equal to negative 5x minus 18. And that is the equation of my line. And if I've done this correctly, if I input this x into this equation, it should pump out that y. So let's try it. Y is equal to negative 5 times negative 4 minus 18. Y is equal to 20, positive 20, minus 18. Y is equal to 2. And that's correct. That is the correct output with this input. So this equation, 18 here, is the equation of our line. Okay, let's do one more example, and then I think you guys will be good to go. And let me make sure I'm still filming. Hey! Look at me go. Okay. So, we've got a line with a slope of -3/4, which passes through the point R at 7, -5. And so my slope is this, and the point they've given me, my x1, y1, is x1 is 7, y1 is -5. So I'm going to pull it into here and then solve for y. So I get y minus my y1, which is -5, is equal to -3/4 x minus x1, which is 7. And now, well, I can rewrite this, so y plus 5 is equal to -3/4 x minus 7. Now I'm going to solve for y. To solve for y, I'm going to subtract 5 from each side, and I get y is equal to -3/4 x minus 7 minus 5. But I want to be in this form, and this form only has one constant. So I have to multiply this out and then combine the -5 with whatever -3/4 times -7 is. So I get -3/4 x plus 21/4. -3 is 21/4 minus 5, but I'm going to turn 5 into a fraction out of 4 so that I can actually add it or subtract it from this. So -5, aka -20/4, because 20 divided by 4 is 5. So now I can actually combine my two constants, and I'll get to this form. And I get y is equal to -3/4 times x minus plus 1/4. 21 minus 20 is 1/4. And then there's the equation of my line. My intercept is 1/4, because if I put 0 in for x, well, it's in that form. So that is my intercept 1/4, and my slope is -3/4. And I can check that by saying, okay, if I input 7 for x, does it spit out -5 for me? So I go y is equal to -3/4 times 7 plus 1/4. And y is equal to -3/4, is equal to -21/4 plus 1/4, and -21 plus 1 is -20/4, and -20/4 is -5, which is the expected y1. And that should be enough to get you going. Good luck.